In this video, we look at matching multiple drone lidar sessions. We use a dataset courtesy of Vertical Aspect, 3 DJI L1 flight sessions, 823 million points. The basic strategy is that first we match one flight session on its own, using the wizard and match passes step. I do not have signal markers for the dataset, so we can't do the XYZ shift to signal markers. When we have matched sessions, then we create a project, import all the data into the project, collect tie lines, and solve a correction per each line or a correction per group, and decide which one is the right type of a correction to apply. So I start by importing the first flight session. I select an LAS file, I select a trajectory solution and SPET out file. And I need to know that my laser data is already orthometric. The projection system is survey feet, so all the values that you are going to see are in survey feet. I take a look at the dataset. There's not much vegetation, so it's mostly nice, open, visible terrain. And I want to use a system for numbering flight lines. First session is going to be 100 and something, the second session 200 and something, third session 300 and something. And I do split trajectories, so I get individual passes. And then we can look at the how well or how badly flight passes are matching each other. So I'm going to look at some cross sections from the dataset. And I can see some mismatch. I'll find some other place. And I can see a place with a slightly bigger mismatch. I'll leave that visible so that I get a feeling for how good is the matching that I get from TerraMatch. I delete transition passes. And I use the wizard match passes step to solve corrections that would match this one flight session internally. Typically I do heading, roll, lever, jet per line. For this dataset I have already seen that I do need to do a fluctuating elevation correction as well. I don't use that all the time with drone lidar data, but here I've seen that it makes a significant improvement. Time-consuming steps in the video have been speeded up, so the steps that we do go pretty fast. And I want to look at the report. The starting mismatch 0.073 gets only a little bit smaller with heading roll pitch correction. Furthermore, with mirror angle it gets again a little smaller, and with per line correction a little smaller, but the biggest improvement really happens with the fluctuating elevation correction. And now that one cross section that I kept visible. It's now looking good. I'm going to save the matched points for this flight session into session 1 folder. And I use fast binary as the file format. Then I can close the points, and I can do the same steps for the second flight session. Again, I select an LAS file, I select a trajectory solution file and SPED out. We import. For flight session 2, I want to use line numbers 201 and something. So I give 201 and I assign group 2 for the second flight session. Split trajectories will then create lines 202, 203 and so on. And again, I'm going to look at some cross-section to see what type of mismatches I have between flight passes. And to be able to see that when I do the match passes, there really is an improvement. Again, I delete the transition flying. Then I use the match passes from the wizard. I use the same settings as previously. Again, I do want to look at the report, what happens to the mismatch. The cross-section looks good now. So again, we start from 0.075 type of value. And the biggest reduction happens at the fluctuating elevation correction phase. I'm going to save these points into session 2 folder. And I'm going to close points, and then I'll do the same steps for session 3. And if I have more sessions, I keep doing these same steps for each session. Again, I select an LAS file, I select a trajectory solution file. Do the import. And now I want to have flight line numbers 301, 302, so on. So I use 301 as the first number for trajectories and group 3. I do the split trajectory. Then I can look at cross sections to see mismatches. On this third flight session, my mismatches are smaller, not as big as in the first 2. I will delete the transition flying. And I will again run match passes from the wizard. The same settings, heading roll, lever jet per line, and fluctuating elevation. I do want to see what happens to the mismatches. Now my starting mismatch is smaller, so it was a better flight session. And again, the fluctuating elevation correction is the final step which makes the biggest improvement on the data. So in this data set altogether, I needed to do the fluctuating elevation correction for each one of the flight sessions. So I saved the third flight session points. I now have 3 FBI files. And I want to do a project. So I'm going to read in all of the data now using read collection, and it finds all the FBI files in the selected folder and its subfolders. And I will read in only every 50th point. And I'm doing this for the purpose of designing my project block boundaries. What kind of geographical polygons I use to divide the dataset. I'm going to switch to intensity coloring. Grayscale works nicely in this work. And I decide on a level 10, where I'm going to draw line work that will be turned into block bounding polygons. It's okay if some of the ends of the flight passes go outside the block boundaries. I'm okay leaving those out of the point cloud that I actually process. So I'm drawing line work on level 10. And I'm going to use a tool in TerraScan to create polygons from the line work that I have drawn. It takes a little bit of practice to become productive doing this, but when you learn to do it, it is quite a quick operation, and it gives you nice polygons for processing. And I ask the software to build me polygons. I tell the software that I've loaded every 50th point, and I want to display point counts. And I want my point count per block to be between 50 and 200 million. And all the point counts appear in white color, except there's one which is 0. So I made some kind of a mistake. So I've drawn an extra line. I get a small triangle polygon in there. So I delete the line and rebuild the polygons. And then I don't have that extra polygon with 0 points inside it any longer. So my design of the block boundaries is complete. I have now polygons on layer 11 created by the software from the line work. I go to define project and I create a and I select the block polygons. I add those to the project definition. And now I have a project with 7 block polygons in it. I didn't pay attention to the attributes, we do want to store color, and the timestamps are GPS standard time at this point. Now I'm ready to import my points. I use the same import collection, which finds all the FBI files in a given folder and its subfolders. And I run the import. I get 751 million points in my project. I also need to use all the trajectories. And now I'm simply using the Windows tools to copy all the trajectory files from the session folders into a combined folder, which I have in the Dowdy folder as trajectory. So I paste session 1 trajectories in there, then I copy session 2 trajectories, paste those into my main trajectory folder, and I do the same for session 3, copy all the trajectory files to my combined trajectory folder. Then I go to Manage Trajectories and I activate the combined trajectory folder as the active trajectory folder. Now I want to check that my numbering and my group numbering is correct. So I select all the trajectories for group 1. They have numbers 101 to 124. I look at the locations, then I do the same for session 2, and I do the same for session 3. So the numbering looks good, both the line numbering and the group numbering. I'm going to collect tilelines, observations of the differences between flight passes. I'm going to do it using 2 macros. The first one classifies by echo, so that we would only collect points from the places where there's only echo laser points. And that first macro had process lines separately on. My second macro has that off, and it searches for plane type tilelines. And I'm going to run these 2 macros on the project on all of the blocks. They're going to write the result into tilelines subfolder. And we don't need to save, we don't modify the laser data, we just create tileline files. So I select Do Not Save, and I will make use of TerraPatch to get this to run faster. So 3 instances of TerraPatch. So now I have tileline files, and now I go to Define Tilelines, TerraMatch tool. I specify the maximum positional issue I may have in the data, and switch Separate Scanners off. And I open all my tileline files, which have been written into tileline subfolder, 1 file for 1 block. With these, I can now test different parameters to solve. My most likely solutions are going to be elevation shift per line and elevation shift per group. And elevation correction per line gives me 0.0144 as the final elevation mismatch. I do define tileline match again, and now I do elevation per line group or flight session. And this gets me close to the same level, 0.01467. So here I would decide that I'm going to use the per group correction, as it gives me almost the same reduction and it is a much simpler correction to apply. Each flight session gets its own elevation shift up or down. So I save the solution file, and then I'm going to apply this solution to the project, creating a new copy. So I keep the original in laser 01, and we create a new copy in laser 02. Those elevation shifts per group. And now I'm simply going to open the project, which is the result of my matching steps from laser 02, and then I would be in a position to start classification. Thank you.